Alright, now what we're going to do is look at the Arduino's other side of the street here, the pins, okay, and what we can do with them. Let's take this for example. If I move this red wire over to 9, okay, this is the same example that we had earlier. Notice I changed the resistor out to be red, red, black, because that is one of the things that made it a little bit brighter. That's the recommended resistor for this LED. And if you are lost about resistors and how to calculate them, check out my previous examples for trying to figure out Ohm's law. Okay. Now, since it's hooked up to 9, notice the LED is now off. Well, what we're going to do is write some code to turn it on, and then write some code to turn it off. Okay, this is the bare minimum, and we can look under examples, basics, bare minimum, and it'll load this. Let's look at very, very minimalistic code here to get started. The first thing we're going to do is dictate something. So under void setup, we're going to dictate pin mode, which is a very common thing, 9, pin 9, as an output. And you could imagine if we had some kind of sensor, it could be an input. Perfect. Now let's design a loop. A very simple loop. I mean, this is not even a loop, it's just saying beyond. Digital write. Now you can also imagine there's an analog write, and we're going to be looking at that here in the next video. So digital write, pin 9, high. Close bracket, semicolon. Alright, so let's take a look at this. We'll upload this sketch. First we will compile it, and then we will upload it. What happens? LED turns on. Ooh. So think about that for a second. Code being written stating that the LED is going to be on. Oh, that's so powerful. You can't even imagine. So let's have some fun with it, shall we? What if I wanted to go low? Well, I could just type in capital LOW and then compile it and then shoot it back over. Oops. And then, yeah. There we go. Turns it off. What if I wanted to say be high and then be low? Well, I can write another one of these. I can just copy this. Control C. Control V. And we'll make this high. The only difference here is what we're going to have to do is delay the system just a little bit between high and low, because it would happen so fast that we wouldn't see it. So to do that, we type in delay and then how many milliseconds we want. I'll pick 1000 milliseconds. Also, in order for it to be a loop, we have to have both ends being covered as a delay. Let's write this sketch. Oh, and don't forget semicolons. I do that all the time. And a closing bracket. Okay, so let's see what happens. On, off. Perfect. And you could imagine if we were to shorten the delay, let's say 10 microseconds. It would blink. This is now blinking so fast that we can't see it. Now remember, the camera shoots at what, 29.97 frames per second, but this is also being captured via a weird way using Adobe on location. So it pans out to be about, I don't know, about 12 frames per second. Though I'm not going to see that. I'm not going to see that going on. I bet if I did like something like 120 though, I would see that. Perfect. But since it's 120, let's say it's 12 frames per second being captured, if I was to increase that by, let's say 100, I don't know if I'd see it or not. Let's see. But these are fun things to do with LEDs and cameras and stuff like that. The fact is, you have now written code to to turn on and off an LED, a very powerful thing. And you can see it. I'm just at that frequency where it's starting to look like it's both on and off at the same time, and the camera doesn't know what to do to autofocus. It's confusing it. Very cool. Now that's how you write a digital high, digital low situation to a pin. So let's look at the analog version of this using the analog write feature and how pulse width modulation would work to make this thing blink on and off in the next video.